based on the triggering. Okay, triggering means giving the input pulse. Okay, we can classify the flip-flops into three. One is the level triggered flip-flops, next one is the edge triggered flip-flop, and after that we have the pulse triggered flip-flop. Okay, the gated flip-flops or gated latches or clocked flip-flops that we have already discussed comes under the level triggered concept. Okay, and this is the edge triggered flip-flop, and based on this we have a set of flip-flops, and I will explain it one by one. And after that we have the pulse triggered flip-flop, in which we come across a new concept called the master slave flip-flop. Pulse triggered, okay, pulse triggered flip-flop or master slave flip-flop. And as we all know, in the case of asynchronous circuits that we have already discussed in previous videos, that asynchronous circuits operate or give output based on the trigger in the input, or the changes in the input. Any change in the input will affect the output, right? So in the case of synchronous, we studied a particular an additional entity will be there. It's called the clock, and that's periodically recurring also. Okay, and based on the clock the operation takes place, and based on the clock and the input. Okay, if the clock is not working, or the clock remains inactive, it won't work. Okay, even if the input changes. Here we go for the edge triggered flip flop. Here mainly based on the edge triggered flip flop we can classify it into two. One is the positive edge triggered flip flop, and other is a negative edge triggered flip flop. And each has in the case of design, each has small in the case of diagrams and all, it has only small changes. Okay, we'll go directly into the edge triggered flip flop. The flip flops using the clock signal are called the clocked flip flops. Okay, and the flip flops using the clock signals are called clocked flip flops. The control signals, next point, control signals are effective only if they are applied in synchronization with the clock signal. Okay, clocked flip flops may be positive edge triggered, or it can be negative edge triggered, positive edge triggered or negative edge triggered. Okay, next one is positive edge triggered flip flops are those in which the transitions takes place only at the positive going. Positive going means from a small level to a higher level. Okay, that is when the state transition takes place only at the positive going, that is 0 to 1 or low to high edge of the clock pulse. Okay, and this is about the positive edge triggered flip flop. We also have the negative edge triggered flip flop. Negative edge triggered flip flops are those in which the state transition takes place only at the negative going, that is 1 to 0 or high to low edge of the clock pulse. Okay, please go through the introduction part. Okay. As we have learned all the concepts of clock and all, so we can say that edge triggered flip flops are sensitive to their inputs only at the transition of the clock. Okay, and also we need to understand that edge triggered flip flops are also called dynamic triggered flip flops. Okay, edge triggering, the concept of the edge triggering concept is also called dynamic triggering. Please, if in case the question is asked based on construct a dynamic triggered flip flop, it's same as the edge triggered flip flop. Okay, so this is the point. Edge triggering is also called dynamic triggering. Okay, and this is the logic symbol for all those cases. I have not drawn the clock. It's to make you understand how to draw the clock in such cases. Okay, the logic symbol for positive edge triggered flip flop, mainly there are edge trigger, based on edge triggering there are three kinds of flip flops. One is the SR flip flop, and other is the D flip flop, other is the JK flip flop. Okay, SR means set reset, as we already discussed. We can also call it as RS, and also we can say that it's also another name is SC, set clear. Okay. D flip flop stands for data flip flop, and JK flip flop means it's not based on, it's not the short form of a particular word. Okay, similar to set reset, it's not based on short forms and all. It's called that the name came, in the when we go for the alphabetical order, J is followed by K, right? Just follow that case. Okay, J is followed by K, thus it's called JK flip flop. Okay, no other significance. And this is the negative edge triggering concept, and we should introduce a clock here. And how should we give the clock? This is how we give the clock. That is, we need to draw a line and we need to give a triangle there. Okay, this is actually an arrow type. Actually, we are giving a triangle there. Okay, in the case of positive edge triggering, we need to draw this triangle, an arrow mark, or in case. Okay, and this is in the case of positive edge triggering. And for the case of negative edge triggering, we need to draw a line and mark a bubble there, in order to show it's negative, and then we go for the arrow. Okay. Similarly, here also we go for, okay. This is the case of positive edge triggering. This is the case of negative edge triggering. Let's go through. Now we go directly into the edge triggered SR flip flop. Okay. Actually, here what we need to understand is, in the case of edge triggered flip flop, when we draw the logic symbol, I told that we need to, if it's, I have drawn the case of positive going, okay, positive going edge. Okay, so there is no bubble, just a triangle is there, so it means clock is positive, as I have already discussed. And in order to show that, the pulse is positive, we need to draw an arrow pointing upward. I will show it once again. If this is the clock pulse, an arrow pointing upward should be drawn here in order to show that it's positive edge triggered. If the question is asked negative edge triggered, at the falling edge we need to draw, this is positive edge triggering, this is negative edge triggering. Okay, here in the rising edge we have to give the arrow pointing upward. Here in the case of negative edge triggering, we have to give an arrow pointing downward. Okay, arrow pointing downward. So in order to show that it's negative edge triggering. Okay, and when we go for the truth table, here we have drawn all the arrows pointing upward. Okay, like this. The case of positive edge triggering. In the case of negative edge triggering, what we need to do is, all those cases will be the same, but we need to give the clock as a arrow pointing downward. Clear? Okay. So I think that all those concepts are clear to you. This is the case of positive edge triggering. So there will not be any there will not be any bubble, and it's in order to show it's positive, an arrow pointing upward is shown in the pulse. Okay. And here the S and R inputs, in the case of edge triggered SR flip flop, the S and R inputs will be called synchronous control inputs. Synchronous control inputs, because these inputs affect the output only based on the synchronization, or alongside with the presence of the clock, these inputs affect the output. Okay. that is already shown here. It's as it is positive edge triggering, all those arrow marks will be pointing upward, and when both S and R values are zeros, the present state it will the next state will remain in that particular state itself. And in the case of reset, if reset is positive, it's if reset is positive means the value of reset is 1 means if its present state is in 0 state, we need to continue that state itself. If it's in 1 state, we need to reset it or clear it to 0. Okay. Next is set is 1 state. So what we need to do is whatever be the previous value, we convert it into the positive case. If it's already in positive, it should remain in the positive case. And arrows pointing upward, and when both values S and R are 1, whatever be the values, we can't determine what the output will be. So it is indeterminate or invalid, or we have already learned, okay, not allowed condition, okay. And if the clock is not present, that is zeros, whatever be the values of the input, so we have given X marks, okay. What is the state of what will be the present state, the next state will also have that state itself, okay. So no change condition. Please go through. Next is the edge triggered D flip flop, that is data flip flop, okay. And here we have these are all simple cases. The explanation is also based on this diagram and truth table. You can explain all these cases by yourself, okay. This is how we make a D flip flop from SR flip flop, okay. Here, in order to show its positive edge trigger, I have marked a clock pulse with positive sign, that is arrow marking pointing upward, and also as D is formed by taking the one positive case and the negation of that part, we can say that from SR, if it's S and R, we can construct a D in such a manner, okay. And as far as the logic symbol is concerned, it's very easy. In order to show its positive edge triggered, just draw that triangle clock signal, and also D, and we have Q and Q bar. And about the truth table, there will be two conditions, and when the value of D is 0, whatever be the present state value, it should be made, the value should be converted to 0, that is reset condition. And also check it's edge triggered, so clock signal must be positive, and also that is arrow pointing upward. In the case of D signal, in the case of D, when the value of D is 1, we say that whatever be the present state, the next state will be converted into a set state, that is the value should be converted to 1. If it's already in one state, retain that value. In both these cases, the arrow is pointing upward, that is clock button, that is it's positive edge triggered. And when the clock signal is not present, whatever be the value of D, the outputs, the present state can be any value, and it will be maintained, that is no change condition, that is NC. Please. Next is edge triggered JK flip flop, and as you all know, it has no significance about that particular name, okay. It's just written in the alphabetic order, J as J is followed by K, okay. So there is no much significance in that. But as far as the flip flop is concerned, it is most versatile and the most widely used flip flop, JK flip flop, okay. It is very similar to the SR flip flop. The logic symbol of JK flip flop is much similar to that we have seen in, it's almost the same that we have seen in the SR case, but just the S and R is replaced by J and K, okay. But the main difference is that when in the case of SR flip flop, when both the values, that is S and R was when hold the value 1, the output was indeterminate or invalid, okay. So The only difference is that in the case of JK flip-flop, when the value of J and K is equal to 1, the difference is that it has a toggle condition. Toggle. Toggle. Toggle condition. What is toggle means? Whatever be the present value, when both the inputs are, that is J and K, are the same, that is they are not on the same means, if it's 0 0, it's no change condition itself, and if it's 1 1, if J is equal to K, J is equal to K is equal to 1, then it goes to the toggle condition. Toggle means whatever be the present state value, the next state will hold the reverse value. Okay. For example, I will show you the details. When all these cases are up, that is in positive edge triggered case, when all the clock signals are up, when positive edge triggering, so when both J and K holds the value 0, there will be no change. You have seen. When K has the value 1, it means it's a reset condition, because K is similar to R in the case of SR. Okay, that is, and J is similar to J is similar to S. Okay, and when J holds the value 1, then whatever be the previous value, it should be set to 1 value. And when both the values J and K holds the value 1, if the present state value or the state which is stored in the memory is 0, the next state will be 1. If it's 1, it will be replaced by, or the new value will be 0. That is, if the previous case was 0, it will be the output, new output will be 1, and if it's reverse, okay, you know that right now. Okay, so that means toggle condition, TOGGLE. Okay, and when the clock is in off condition, whatever be the inputs, there will be no change itself. Okay, based on this toggle condition, that is, if we have a particular input, or I mean, if the value of both what we call J and K is equal to 1, we have the condition in JK flip-flop as when J is equal to K is equal to 1, we should go for the toggle condition. That is, if 0 is present, it should be converted to 1. If 1 is present, converted to 0. Okay. Based on this, we have another flip-flop which we will follow right after this. Okay. It's called the toggle flip-flop or T flip-flop. For the time being, please go through. Okay. Next is edge triggered T flip flop, and T stands for toggle. Okay, it has only one, that is, it's a single control input flip flop. That is, the single control input is T, and we have two conditions in JK flip flop. That is, when J is equal to K is equal to 0, and when J is equal to K is equal to 1. We have two conditions. So, what's the significance of T flip-flop is that, it's made, we can construct T flip-flop from JK flip-flops. See, both these inputs, and we are not giving the inverse as in the case of D flip-flop. We created D from SR using one input and the complement of that particular case. But here, we have both the cases, that is, T is given to both J and K. Okay, based on that, we have two conditions. One is J is equal to K is equal to 0, and other one is J is equal to K is equal to 1. Okay, similar will be when, see, as this is given to both J and K, we have J is equal to K is equal to 0 condition and J is equal to K is equal to 1 condition. Okay, and for both these cases, we have written just one input, that is T. Okay, this is the logic symbol. We have T input, and we have a clock signal, and we have the Q and Q bar. Okay, and what about the what we call the truth table? In the case of truth table, what we understand from this is that when the value of T is high, on each reception of the clock pulse, the particular state is changed. Okay, when clock is high, value is T. Okay, sorry, value is 0, that is when value is low, that is when the value of t is low, whatever be the values we have already received, that will be presented to the next level as well, or the next input will also next state will also be the same. That is when the value of t is low, that is 0, no change will be there, and when the value of t is equal to 1, we should understand that it is going to be the toggle condition. Okay, on each giving when we give each trigger or pulse, the clock pulse, when it is high, in the case of here we have positive edge triggering. Okay, when each positive edge trigger pulse is given, when the value of t is high, it will toggle. That is when present state is 0, next state will be 1, and the present state is 1, next state will be 0, likewise. That's toggle condition. Okay, and in the absence of clock pulse, whatever be the value of t, no change takes place. Okay, so when compared to the truth table of JK flip-flop, we had two conditions there. When j is equal to k is equal to 0 and j is equal to k is equal to 1. Based on that, we make the T flip-flop only based on that two conditions. Clear? Please go through.